just discussing circuits. So glad you decided to join us today. Today we'll learn how to design a audio amplifying circuit in parallel with a vumeter.
Alright, so the first step in creating our audio amplifier in vumeter would be to create the audio amplifier. And to do that, what we're going to want to use is an op amp, and we're going to want to use the non-inverting configuration of an op amp. So what that looks like when we would draw it on paper is this. So the op amp is an active circuit element, meaning it requires an input voltage. In this case, two actually. We have the high voltage input and the low input voltage. Those are kind of the parameters the op amp works around. It can only output this high or this low. Here we have this goes into the negative sign, as you can see on the op amp, so that's the inverting input. This goes into the positive sign, so that's the non-inverting input. And I'm just going to put since it's non-inverting, our Vin signal goes straight to the non-inverting input. To calculate the gain, what we have is in parallel with the inverting input and V out, we have this resistor RF. In series, well, I guess in parallel with that also, we have this resistor out here called RI. And this inverting input is grounded because we want it to be non-inverting. So from here, what we have is, if you look at node voltage analysis, you'll come up with V out equals 1 plus RF over RI times V in. This term right here is called the gain of the op amp, which is 1 plus RF over RI. How you would breadboard this, looking at this, we have our Vin goes into the non-inverting terminal. So here, on this picture, you can see this is the non-inverting terminal, and it goes to pin 3, so we'd connect Vin right to this one. You'd connect your negative source there, your positive source there, and now we have V out, which, I'll just draw these wires, we have RF between those two. This will be our V output coming out of that. And then from here, we have RI, and then this is grounded. So that's how you would work with this chip to make that circuit.
When dealing with an audio amplifier, you're going to have two outputs, one for the right headphone and one for the left headphone. And so op amps have a pretty neat deal where you can have two outputs. As we see in this picture already drawn, you see that there's, sorry my shadow's in the way, you see that there are, there's actually two little things in there that allow us to give that. So over here we can draw this, and so we'll basically draw the first thing. So for our first output, here we would have the V out 1, and then we have one of our inputs. We've got the resistor there, and then here's our other input, which is where our voltage is going to come in, and then this is our V negative, so that's going to be our negative voltage, and then up here still the same. It's going to be the same for both of them. You have your positive. And then now is where it kind of gets a little bit different, because we're going to have start putting our second input, and it's almost a mirror image to this side. So right here you would have this is going to be your V out 2, so you can say like this is going to be your left side, and this is going to be your right side and whatnot. and then here you just have, since we're doing a non-inverting, the inverting will go to ground with the resistor Ri, and then this will be the V input from our voltage right there. Now, when we're also dealing with audio amplifiers, we want to amplify the sound, we want to make it louder, and to do that we need a volume control. And one of the neat things we have to do that is a potentiometer, which we can use in this equation right here of our V out equals the 1 plus, and we're going to change this RF to become R pot, which is the R potentiometer, over the Ri all times the V input. So you can see this equation right here. Now the VR pod is going to allow us to change the gain, which gives us more voltage output or less voltage output, which in turn will make the volume either louder or quieter, which is the goal of this, which is going to be the goal of this circuit.
All right. As we've previously described, to make this audio amplifier, we're having a non-inverting op amp with a potentiometer here as the resistor in parallel with the inverting input and the output. So what we've done here is shown you how to work with this chip on a breadboard, treating this green line as ground, the red line as positive, and the blue line as negative. Here we've connected from positive to this V plus up here, the top right pin. The negative we've connected to the bottom left pin, V minus. Into the inverting side, green is ground, so we've connected from ground to our input resistance, which this one is 2.2 kilo ohms. We've connected that to pin 2, and also in parallel with pin 2 and this top pin right here, which is the output voltage, in fact, which we've drawn a line from right here, this yellow line. We have this 50K potentiometer, so this swivels between 0 and 50 kilo ohms, adjusting the RF in this equation, so it'll be anywhere from about 1 times Vn to 1 plus 50 over 2.2 times Vn, which, given the constraints of the input voltage plus or minus, I'm sure will be saturation. But so this is what that circuit would look like on a breadboard.
Okay, her recording.
All right, so the second half of the audio amplifier and VU meter would be the VU meter. For this circuit, you're actually going to want 2 because you have 2 op amps with 2 outputs, one for the left, one for the right for stereo sound. So you'll want 2 VU meters, one for the left output and one for the right input to show, I guess, what you'll be hearing with your left and right ear with your headphones. This is the schematic of what the VU meter is. So essentially, this left to right signal will be your signal in at 5. The idea behind this is you have 10 LEDs lined up. You have this positive reference voltage here that goes to this, goes in at pin 3, but it also loops around to the top parallel with all these lights and the mode. Putting the positive voltage into the mode puts it in regular instead of dot mode. And essentially what this chip does is it has a comparator at each of these inputs, 1 and then 16 through 18. If this signal in is equal to V plus, all 10 of these will be lit up. If it's equal to some fraction of V plus, less than V plus, a corresponding amount of these will be lit up. So it basically shows you the strength of the signal coming in compared to the input voltage here. So in order to make this chip work, you have you ground pins 2 and 4. To smooth out the voltage from the AC source here, we put a 10 microfarad capacitor in parallel with this pin 2, and the first LED. So this first, I guess this is the input voltage coming to be compared to this output to the V positive. The V minus terminal gets connected to that and the negative input voltage. Pin 3 was the positive input voltage. Then pin 1 starts up your sequence of 10 lights over here. So that's kind of your input, and your outputs go through here to light up the lights. Over here you can kind of control the brightness of the lights because pins 8, 7, and 6 control the output voltage at these terminals. And what you can do is you set your R1 to 1.2 kilo ohms or 1000 kilo ohms, and then between this connection to 8 in parallel with R1 and ground, you can put a potentiometer. So when you turn that potentiometer, you'll be adjusting how bright or dim these lights will be when an input signal comes in. So that is the schematic and how all the pins work. As you can see here, we've breadboarded it, treating this negative as ground, this far negative rail is ground, then positive and negative here. We have the capacitor, the 10 lights all connecting to the corresponding pins, and then we actually didn't even mess with the potentiometer here, but that's how that circuit will work. And so essentially you'll have to construct this circuit, solder it together, and then solder the signal pin 5 here in parallel with the left to right audio output signal, and then create another VU meter and connect it to the other audio output signal.
So this is basically what a packaged final project is what you're going to want to look like. You can see we have our 2 VU meters up top here, so that the lights will go will be orientated down as it gets louder. On the side here we have our switch for power, so you can switch it on, and we'll switch it on to see, oh, there's some lights, and that works. And then down here we have our potentiometer, and this will control the volume. This is for the input, so we can hook up, you know, if you want to hook up your iPhone, your computer, anything that has an audio jack in it, you can hook it up. And this is where you'll hook up some headphones so that the music will be amplified through there. Now, in doing the circuit, we can open this up here, and we can see that we have a very intricate circuit going on. Connected to the top here, we have our, these are going to be the 2 VU meters with all the, you can see there's the V positive going across all there for all the different lights. And then this is going to be the actual audio amplifier. When you look at it, you can see here's the op amp and the 2 resistors for both the right and the left side. And we have 2 batteries for a positive 9 volt and a negative 9 volt source for the op amp. And you can see it runs to a switch that goes through, and so all you're going to do is close it back up, you put the screws on, and theoretically turn it on and pray that it works. Switch on, music on.
Alright, I hope this has been informative, and thanks for your time. Have fun with your audio amplifying circuits.